Alright. Hello. This is a programming stream. I haven't done one of these. Well, I did one yesterday, but I haven't been doing a lot of programming streams. We should get back into these. So this is something I worked on a bit ago. I don't actually think I have a working version of this, but basically generating a caption, and then this specifically is training a neural network to break the caption. Let's actually see if we can get this running. I have it running a million iterations, which is probably too much. Oh, here we go. Train iterations. I have it as a constant somewhere. So let me see if I can get this running. So this trains a neural network to identify the captcha that I generate. So you can see here, it's not doing well. It identify. So if you can tell, this is 0, this is 1, this is 2, this is 3. I don't know what this is. That might be 4. This is 5. This is 6, 7, 8, 9. So it's actually kind of hard to tell. These I actually think are pretty decent captchas, but as you can tell, it is throwing the basic neural network off of it. I haven't even been paying attention, or I haven't done this for a while, and I haven't read the code yet. I don't even know how many layers there are to this neural network. There are 8 hidden layers in this network. So, yeah, okay, there's actually a lot of layers. So if I remember, I was actually able to get the neural network detecting these. Still learning rate 1. And I can't remember, is this doing TNH neurons or... Ah, no, this is doing clamp -1 to 1. So specifically, this program is generating a captcha. Where is it? Is it regen or captcha right here? So this generates a 2D captcha image using JavaScript's Canvas API. It draws text and then applies noise and some distortions. And then it trains a neural network to try to detect the captcha. So right now this is an 8-layer ReLU neural network. I guess it's convolutional. So this is the captcha thing I was talking about. These are the captchas where it's like this is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. You'll be asked to basically enter numbers. And then I'm training a neural network to try and beat the captcha, because the whole idea is that if I can make a captcha that a neural network can't easily beat, it's probably going to be a pretty good captcha. I might need to change some of these hyperparameters for the neural network. This learning rate multiplier is really lowering the learning rate. Too much, I think. Let's try this. So right now I'm just messing around with the values for the neural network. we'll leave it here. It'll take a while to train. So you can see this is the loss of the neural network very slowly going down. Yeah, that's what makes me think the CAPTCHA is actually pretty good right now, is it is difficult to identify. But that is the other thing, is I might not have good hyperparameters. Man, this is this really annoying thing about neural networks and stuff, is like, you could technically use a neural network to discover better hyperparameters, but then you need a neural network that, okay, so it's detecting them all wrong. Alright. It is detecting them wrong. So I'm going to try a different way. We're just going to do a low learning rate like that. I seem to remember that working well. Oh yeah, that's actually training faster now. So this is the interesting thing about neural nets, is you could actually evolve a neural net to find the best parameters for evolving a neural net. And like I've been wanting to like write a blog post doing this and basically just like start working towards that, but then it's like a whole thing of like, that's a rabbit hole in itself. But at the same time, that's like the ideal thing, is you don't just like you don't have my neural net figuring out these parameters. You use your neural net to figure out the parameters. Okay, it's still not, it's overfitting or whatever. Detecting this is 8. Qualifies as 9. Oh yeah, okay. Maybe I actually did have good values for that. Because they are not identifying. Am I doing RMS prop here? I don't think I'm doing RMS prop. Train. So RMS prop would be keeping a running average and then multiplying the learning rate like here. Or maybe I multiply it in the back state here when I do t-sum. Divided by dv. No. Yeah, so this actually isn't that great of a neural network. It should still train. But I think I'm going to reprogram most of this. I want to see if I can get this working though, because if this does work, that will be nice. So these are the settings at the beginning. That actually doesn't look like it's horrible for training. It's kind of chaotic. Nope. So either my CAPTCHA is really good or my neural network's bad. I think my neural net is bad. Yeah. It looks like I'm doing TANH backpropagation, but I'm not using TANH. This neural net actually has some bugs, or like it's not written correctly. I can... Oh wait, it is using TANH. I don't know if my derivatives are so big, but I don't know why I need such a small learning rate. Like, I guess I'll just try leaving this training for a while. Actually, wait. I'm gonna remove the noise. And let's see if it can identify it. So what does this look like now without the noise? So that's 0, 1, 2, 3, 4, 5, 6. So having them mirrored definitely messes with it. So now let's try a higher learning rate. Yeah, it actually does not seem to be training well. Even with these simple CAPTCHAs. I think I'm going to change up the neural net. I actually wonder if the settings I had at the beginning were good. Yeah, wow. Even with this, the neural net is struggling. Alright, I'm gonna go get some water. I'm gonna leave this training for a good little bit and give it one last try to see. Do a decently small learning rate. If it can't train after this, then that'll be stupid. I definitely think I have some bugs in this neural network code, so first thing I'm gonna do when I'm back is rewrite the neural net. We're gonna use a simpler neural net too, and then just use one where we can just scale up the number of neurons easily. Alright, it's not training. This neural network sucks. So we're going to copy and paste that. And we're going to rip out this old neural network code and write our own. Well, I wrote this too, but we're going to write simpler neural net code. I don't even know if I'm going to do a class. Why do I have these rotate 2D functions? What was I using these for? Retraced reflective plane. Ah. Okay, yeah. It didn't identify any of them correctly. That neural net is broken. Alright, so generate sample images. Oh yeah, so part of the issue with this may be that it's training on the same images over and over again. Regen samples every once in a while to randomize data. Where is it actually? I think I have a file called neural matrix. That's actually like the type of neural net I'm looking for. There we go. So yeah, I'm just going to use that. I guess I'm just going to copy the code in. It's easiest. I'm just thinking because I had the trainer class. I still need to do everything the same pretty much. Target derivative. So we got our samples, elements, results, digits as samples, sample width, sample height, training iterations. I don't know what cqualify is. I guess it's just some data variable. Neural net, neural trainer, note I. So we need a matrix. So the input size is going to be sample width times sample height. The output size is going to equal 10, or the number of digits. I guess that could be constant. And then I'm going to need to create input and output buffers. I just realized I don't think there's any reason I need to initialize these here. I can just initialize them up here. So this is basically going to be a matrix that takes in the values of the pixel values of the CAPTCHA image and attempts to transform that into classification values of the different digits. So basically, like, hopefully if you feed in the image for 0, it'll give you a higher classification value for 0. And then the whole idea is if it can't detect this just from the direct pixel values, you can actually split the pixel values into, like, I don't know, like quantized vectors and split this even more. It'll make the matrix bigger, but it trains very fast. And that's the nice thing, is you know the neural network is basically gonna, or the matrix is gonna train towards the goal. That actually might be something that I work on. There's like a bug flying around. God damn it. You see me randomly clap, that's what I'm doing. I'm trying to kill it. I might, that's actually another test that I've never really done, is splitting up the values into like piecewise vectors for the matrix. I might do that today, or try to do that. Because that's actually something I'm not even sure if it works. Okay, so this copies the data into the float array. This repeats over and over again to make set timeout more efficient. So let's see, I do state.set samples. What I actually want to do here is matrix, is it run? Yeah, run samples. Wait, what variable is SI? Oh, epoxmod 10. And then we can still run this, finding largest qualifier. I don't know if we need to normalize it either. Yeah, do I actually need to normalize this to train it? First of all, I have to change this because now it's just based off output. I don't know if I should normalize this using abs or normalize it with like Euclidean square, using square average. I'm gonna put some music on and concentrate. I guess we can try both here. Alright, so this is trained to be the target. So this is normalizing it and shifting them to be negative. I actually don't think I want to normalize them though. Do I automatically have normalizing here? Normalize input. InSum plus equals input. So this is normalizing input. No, yeah, so we can I think normalizing this is best here, or basically scaling this up based off this. And then instead of adding 1, adding the sum here. So 1 would be... yeah. It would basically be the same thing as 1. If you're normalizing it. Do I keep track of loss anywhere? Should I... yeah, I'm not even gonna track loss. We'll keep this minimal. So what is training again? It's input, output, error, precision, I think. Input, error, precision, okay. And then we can mess with different precisions here. I'm going to go with 0.5 to begin, or maybe 0.9 to make this go fast. And then we print results. Alright, so what is this printing? Oh, this is checking if they're all qualifying. Oh. Oh, so this stops training automatically when it's working. That's actually dumb. Because there's times it could actually get them all correct, but then it's not like perfectly trained. Because it's randomly generating the CAPTCHAs, or it has like random distortions. Why is autoplay not working? Alright, so then when this is done, puts the image data and displays them so you can see all the CAPTCHAs, and then it shows the final result. Okay. So, I think this might work now. Or not, it maybe won't train correctly, but... Oh, I'm opening the wrong one. There's some error going on. Alright, let's see what it's like when it trains. Alright, so it's identifying all of them as 0. Pretty sure this is because of the different colors. So if we make the background constantly 0 and the foreground constantly 1, I think. No. Still couldn't train. Okay. Alright. Alright, let's see if we can at least get them basically identifying. Oh my god, I'm not initializing the matrix. Derp. Okay. Alright, so it identified 1 correctly, 2 correctly, 3 correctly, 4 correctly, 7 correctly. So let's try messing. We've only got 1,000 training iterations. Let's try changing this rate and see if it makes it better or worse. 0, 0, 1 is 0. Too much. 0, 0, 1 is 1, 2 is 2, 3 is 3, 4 is 4. There we go. Okay, it's correctly identifying the basic letters. So now let's try adding the distortions. See, I can't even identify that one. Okay, so it got 8 as 8, it got 7 as 7. So if I had to guess, I just need to train it more and it will actually be able to get this still. I'm gonna try changing the training rate. That made it worse. 0, 0. Alright, so now this is going to take a bit to train. 100,000. I should probably list loss, I guess. Oh, it's kind of identifying 4. So I got 4 is 4. It got 6 is 9, which actually kind of makes sense because 6 does kind of look like 9. It got 7 is 7. Okay, so it's kind of correct. I think we had enough training iterations. I'm going to try changing the training rate or precision. Oh, okay, so that gets them all to 0. That eventually hits 0, 2. I think this takes so long to train because there's so many like combinations. Yeah, so 4 and 7 seem to be easiest to identify, and I guess 9. Interesting. So let's try a way lower training rate. Just as a test. So it is getting 4 and 7. And it seems to be doing better on like 2 as well. So we got 0, 2, 4, 7. Alright, it was way better that time identifying. Oops. Huh. So I guess let's try a mix in between. And then I'll try changing the code. So we might need to have some extra processing here. What if I do max value here instead? I wonder if that trains better or worse. I guess I'll try adding this normalization. So that trains worse. Oh, that actually seems to be kind of working better. It's training to 1 there. And 2 is sort of honing in. Interesting. So what is this specifically doing here when we're normalizing? Let's try doing it. Squared average. That immediately looks worse. Yeah, so what are we doing here? We are averaging the output values based off this, which will then end up averaging the training. Huh. The inputs will be normalized, so they don't really matter how big the output is. Okay, actually, yeah. I think what I was doing before is better, because that, or this, with normalizing the output, is definitely good, because now we know that this will add up to 1, and that, and then it'll train each one equally. I'm just thinking here, I might measure the loss, because I can easily count this up. and it would be give me a better measurement of how close they're getting. Oh, interesting. So now that I don't have this, now it's not training to 0 now that I'm normalizing it, which is actually really good, so I can get a higher learning rate, I guess. Or hopefully, let's see if this works. It does look like it's locking onto the letters like 2 more. We'll go for like 0.8 or something. And then I'll try to pump it with like really high iterations. And we'll see if after all these it trains. I have a feeling that there's just so many combinations of different like positions of the letters in the CAPTCHA that it actually is like having trouble training this each time. Like just doing like the rough calculation here, if there's 16 by 16 pixels and each of the letters can be moved to a different position, and then those can be like, actually how many random values do I have here? Random value here, random positions. So we've got about 200 random positions, and then random, I'm not sure if this is skewing. But I think it's safe to say we have a few thousand combinations per letter. And that could totally explain why it's really having trouble. Or we just gotta find a better learning rate or precision. Also, I actually just need this to be a bigger value, so I probably can modify training this to put out a value of 1 might not even be the best thing. I may just need to shift this to make it bigger than. So this seems to be dithering too much back and forth. I actually do think I need a lower sort of learning rate. I think, yeah, part of the issue is as well that it's trying to push these up to 1. Even if it's like negative and it's already bigger than it, it'll push it way higher up, which can actually throw off other numbers, like, since they're all part of the same. Actually, no, they're not necessarily all part of the same matrix, because this isn't like a neural network where they actually could be sharing hidden neurons. They're actually all separate, so. Maybe I just need a really low learning rate. Oh, wait. I just realized this is trying to push them towards 0. But even if they're negative, but if they're negative, that actually is fine. We don't need to push them anywhere. So what this should actually be is math max 0 negative. What is this? We're trying to make a CAPTCHA and beat it with a neural network. And right now the neural network's having trouble. Except for, you can see 2, 4, and 7, it's actually getting the majority of the time. 4 qualifies as 4, 7 qualifies as 7, 2 qualifies as 2 most of the time as well. But it's basically training a neural network right now on our CAPTCHA. So I guess the CAPTCHA is pretty decent already. Brute force? Nope. No, it's training it. It's taking the difference between what it should be. Alright, let's try raising the learning rate again. I gotta think about this though, like, can the Matrix actually detect so it's like if we've got like a 7 and then like a 1, it can like detect the 7 because the pixels are different, like differently offset than the 1. Maybe it's because actually with this system it's only working off of this. It also needs to work off of the negative space. I actually wonder, what if I put in the dark areas as negative? Let me try that. When I do the samples here, so if bigger than 127, 1 or negative 1, so now I can also use the negative values, I think. No, it's still able to get 7 and 4 most of the time. It actually looks like it's getting 1 better now. It's confusing 1 and 7 though. You know, part of the issue might actually be that I'm training these all in a specific order. I should probably actually randomize these samples. Or randomize the order. What is NDAT? Alright, well, we'll create another array for storing, we're going to store the order. We'll call it hat. No, we'll call it order. So then when we regenerate, we set order. Okay, actually we need another array for what's called the hat. So we fill the hat at the beginning. And then we generate random indexes by pulling out of the hat. This is actually doing pretty good. It's getting 1 now and nearly getting 2. Does splice return the index in the array? It does, okay, nice. I don't know if I want to use that though. So random index in the hat. Randomly pull out of the hat, and then we splice that out of the hat. We could also do a fast remove, but I'm lazy. Well, hat ri equals hat. We'll just do splice. So then sample index here, we will do sample index equals order sample index. So we actually use the randomized order from here. And yeah, that should give us random sampling. Hopefully this will train better. I guess I could run multiple of these training at once, because it's browser tabs. Let's do it. So this one's with 0.8 learning rate, this one's with 0.333 learning rate. Actually looks like the 0.8 is training faster, which would make sense. It's a higher learning rate. I guess that would mean it's not causing issues though. It's interesting how it has trouble confusing 7 and 1. or it has trouble determining between 7 and 1. The same thing's happening over here. It's going between 7 and 1. I guess they kind of look similar. I'm just thinking, will this work properly? I guess so. It definitely didn't make huge changes to the training. It still seems to be getting stuck. It might be doing better though. That's the other difficult thing, is it's like really hard to tell. Do you think neural network can work for market prediction like trading bots? No. I've heard that algorithmic trading is horrible and that you basically lose money, because you'll train a neural network on like the data from 2010 to 2020 and the neural network will be like, oh yeah, I figured out all these patterns that let you make money off the 2010 and 2020 data, and then you start applying it to like 2021 data and that shit does not work. The way people imagine it is that you feed like market data, like the charts of stock prices, into the neural net and it predicts from that. But I think the realistic thing is you almost get something like Skynet, or like probably what company is it? IBM, or whoever it is, whoever the companies are that are making like Watson and the big information database AIs, I think that, where it collaborates information across like news, like it takes into account politics, like future weather patterns and things like that. Like, you know what I mean? It's not just like stock prices, it's like correlating that a future weather event is going to hit someplace and that's going to cause stock drops in that. Like, you know what I mean? That would be the type of AI that like gets a head, I don't know if you'd say head up or an advantage. I think there's something wrong with my neural net or something. It's not really a neural net, it's a matrix. AI that predict best day of the week for trading. Wild idea. It might work for a bit until it doesn't. And that's the huge issue, is whenever it doesn't. If either of these got any more stable. Yeah, I'm gonna start looking at loss numbers. I feel like I don't have full information here, and loss would make a lot more sense. So I think I'll just do loss from this. So if this is positive, it'll be negative. Okay, let's see what these values are like. Okay, that is way too big of a number to display. Fixed with 3 decimal places. Alright, so our loss starts out pretty high at like 0.8, 0.7. We got a few down at 0.7. Alright, so this is actually really good that I visualized that, because I actually thought the loss was way lower than that. Let's see if we can get the loss go down quicker. Loss to go down quicker.
Instruments destined for planetary landing may be assembled with minimum risk of bacteriological contamination.
Yeah, it seems capping out at like 8. I feel like there's a better way of doing the training like this. Let me try taking this away. Does that make the loss numbers go up? Yeah, I think that did slightly push up the loss numbers. But it still looks like 4 and 7 are training decently. Oh wait, we actually don't want to max 0 this if it's this one. So we want to limit all of these except for this one. I'm not sure if that would actually help, but let's try it. This way it's not pushing it up all the way as it could be. Oh, that might have helped the loss. Let me try a very low learning rate. I'm almost tempted to try doing brute force evolution for this. Because I know for a fact that brute force evolution will find the solution. It's just a question of time. Still getting the same results though. 7 and 4 and 7 and 4 are the only consistent ones. I think that lowered the loss a little bit. And that didn't seem to make any difference. And I'm assuming if we stop regenerating these each time, it'll train very quickly. Yep. So what if we split up the regeneration? Into like mini batches. Oh, so it trains lower and then spikes back up. But it actually seems to be focusing in on them better. That actually might be it. Let's try this. So it keeps changing and then they focus in on it. So I wonder if it's actually going to be able to train down to them now. It seems to have kind of messed up now. Zero qualifies as 0, 1 qualifies as 1, 2 qualifies as 2, 3 qualifies as 6. Yeah. Let me try lowering the learning rate. Yeah, so the loss progressively gets higher and higher after a few changes. Like, the changes actually throw off the network. Maybe it needs a longer time to process the changes afterwards. So like, what if instead of doing mod that, we did mod plus iterations? That'll actually probably cause issues. So now giving it longer to get back down to lower losses after the changes. I wonder if after doing this a few times it'll actually become pretty good. So that it will get it correct even after switching. So right there it actually just got a few numbers correct after the switch. Interesting. Okay, so 0 is 0, 1 is 1, 2 is 2, 3 is 3, 5 is 5, 6 is 6, 7 is 7, 9 is 9, 8 is 8. But yeah, that's still not predicting them changing or being different. Maybe they just need a long training time. Let me try random training amount, so some have a little bit of bias. Nope, that looks the same. This one's even spiking up to 1. Well, it's actually kind of focusing in on 1 and 2 here. I have a feeling if I leave this for long enough, it will actually succeed. Let me try making it simpler. Wait, is this part of the rotation matrix? What am I getting wrong about this function? Sine... Alright, I gotta look up this transform function. Horizontal scaling, vertical skewing. Yeah, so this is the matrix. Wait, it's skewing. Oh my god, I'm dumb. There we go. Now, why is that cut off? Okay, they're offset too far off the screen. 0, 1, 2, 3, 4, 5, 6, 7, 8. Okay, so let's see if it can detect it even when they are far off the screen like this.
Is John Morgan, now a retired professor of pharmacology.
It's still struggling, but less. It's able to get 2 here. 1 is 1, 2 is 2, 3 is 3, 4 is 4. Alright, cool. So let's try and get this working better now. See how many iterations it takes to get consistent. Try and find some better parameters or something for this. I wonder if it would work better with negative.
Marijuana.
That doesn't look like that changed anything. Huh, lower learning rate might actually be the fix. Is the guy singing Russian?
Welcome to KX Cybernetics System. Upgrading firmware version 3.5. Brain connection will be disabled while upgrading.
Alright, so it's kind of working. It's getting 2, 4, and 7. Can barely hear. I finished it now. Or I click next song. I think I heard Rostov something, Rostoval, something like that. I can definitely see why this is having issues. I wonder, what if I applied a wavelet transform to this? Alright, I'm gonna go have lunch, go take a break. I definitely have some more ideas for this, but this right now definitely is not working. I actually just realized something as well, so this is actually good, because this is what I was doing to visualize it. So, shit. Okay, so say you got like a 7, right? And then say you've got a 1. And so like these values, the image square is like a giant vector that has like 256 values, like a value for each pixel being fed in. These pixels that are active have a value of 1. So what the matrix is basically doing is trying to find a way to add these and subtract these in a way to classify that it's a 1, or in the case of 7, a 7. But the interesting thing is these have overlapping pixels in these different places, so it can't just add up these. It needs to choose certain pixels to actually be a subtractive measure, to go like, oh, this pixel right here is part of 7. So like the matrix is a collection of scale values. So if the pixel isn't included, it actually needs to make it a negative scale value to take away from the classification, but that is also, that conflicts with that conflicts with the other numbers, where like they have the same pixels active. Like it has pixels that it needs to be positive scalars to put towards classification, but then those pixels are also negative in other numbers, so it needs to take those away from classification, and those conflict, and basically ends up. So my idea is I can feed that through a wavelet transform or Fourier transform, and it should actually calculate the difference between the pixels to each other. The Fourier transform would give a smoother approach, and the wavelet transform would give a blockier, more aliased one, so I'm going to try both. But then I also have an idea of, I swear there's a way to like get them to maybe figure out to choose which pixels it identifies by. Either including the negative so it can train by that, or I guess before I end stream I will try this, or adding a big random multiplier to the training weight. So some numbers it completely trains way more than others. I guess maybe I'll leave this for like 10 million while I go for lunch, and we'll see whether or not this works. So if this doesn't train by the time I'm back, or if this doesn't figure it out after 10 million, then I mean shit, eh? Alright. So I'll leave that running while I go. I'll probably be back in like 2 hours or so, do more programming. I think we might work on the JavaScript engine today. Just get like, I actually think I've been thinking of working on a little platformer game. I feel like a platformer game is such a good like project to. What I've said is I need a tiny project that's pretty simple, but it tests out features of the engine. And a platformer tests out the physics engine. You can do stuff like particle effects, a lot of things. It'll be good for testing out the engine. And like potentially you could even do like, it gives room to do more advanced stuff as well. Like you could do a map editor for the platformer, and that's like, I mean, map editor is key for an engine. Alright, thank you for watching. I'll see you around. I hope you have a good day, good afternoon, good morning, wherever you are. Bye-bye.